It's a tough crowd. It's a tough crowd. Well, it's because I'm the only one that stands between you and the free drinks, courtesy of Double Cloud. So I guess you've got to bear with me for a little bit. Thank you for joining me. As mentioned, my name is Emily Gorcenski. I am a consultant with ThoughtWorks. We're a consulting company. I'll get into that in a minute. I promise this is not a sales pitch. It's actually just us talking about our experiences. But one of the things that I've learned and seen as a consultant is data architectures of every sort, data problems of every sort, and data solutions of every sort, some of which work, some of which don't. And I'll just be honest, we have been part of all sides of that coin, building things that are really adding a ton of value for our clients, and we've had some misses as well. So I want to talk to you today about a little bit of both of them. What are the lessons that we have learned by building data mesh in practice for the last 4 years, and hopefully impart some wisdom and inspiration on you. I think that you probably know a little bit about data mesh. My colleague Arne is here. He spoke about it earlier today, I believe. I didn't get a chance to see the talk because I was predisposed. And there's been some other talks about data mesh here today and yesterday as well. At the end of the day, what data mesh is really all about, it's about reorganizing your business to get value out of data. That's the easy way of saying it. The more complicated way of saying it is that it's a socio-technical paradigm to decentralize data product teams around domains. That's also a complicated way of saying that data mesh was designed to address a simple question. Why did the DevOps and Agile revolutions not land in the data space? I've been doing data for many, many years. I've been working in data ever since data was invented. No, that's the joke. Ever since before the term data science became popular. And I've seen the same problems over and over. And as we worked with our clients, we also saw the same problems over and over. We had very centralized data teams that were being a bottleneck to other teams that needed to get value. We saw data quality issues at scale. We saw data reliability issues all over the place. And we started asking, why is it that, things like test-driven development and microservices and continuous delivery, why didn't those practices come into the data space? And the more that we looked at it, the more and more we started feeling like, hey, you know what? Data feels a little bit familiar. Data kind of feels like ops used to feel like 10 years ago. Right? Data was kind of like, you compile a thing, you get some data and you put it into your bronze layer, and then you have to put it into your silver layer, and then you have to throw it over the fence, and somebody makes it into the gold layer. And all of these handoffs for data that were just adding time and taking away from the fluent flow of data through the organization to bring value. And we said, that's how we used to build software. It used to be that a programmer would develop some software, they would compile it, they'd have some artifact, and then they would ship that artifact over to an ops team. That ops team would put it into production, then they'd find a bug, and then some developer or some ops person or both would be up at 3 in the morning on a Sunday night on a holiday weekend trying to figure out how to fix it. And that was miserable. It was miserable for everyone, and so we developed better practices. Data mesh is perhaps a somewhat naive way of us coming to it and saying, what happens if we were just decentralize working with data in the same way that we decentralize building software with containerized deployable units on self-service infrastructure and made domain teams responsible for their own data. And so when we started looking at theorizing this, and when Zhamak Dehghani, who's a former thought worker who wrote the book Data Mesh that you see here, when she started, sort of socializing this theory throughout our organization in 2018, 2019, we started thinking, okay, what are the principles that we would need to embrace in order to work in a decentralized fashion with data? We started thinking about things like domain ownership and data as a product. We started thinking about how would you make the infrastructure self-service? And then we started to think about, well, how do you answer the governance questions that come along with working with data? How do you decentralize a fundamentally centralized function within the business? And so we came up with these 4 principles: domain ownership, data as a product, giving data the love and care that we give our products, having SLOs attached to data. I'm going to be speaking about that tomorrow. We decided, you know what, you need self-service infrastructure. You can't have database administrators retaining iron-fisted control over data warehouses. You actually need to have people able to build and deploy and experiment and to fail and to be able to recover autonomously. So we need the infrastructure that can do that. And then, of course, the governance, we said, what are the essential functions of a governance team? We want them to be able to enforce standards and to promote trustworthiness of the data. We want them to address legal and compliance and security concerns. But what happens if we were to automate a lot of that? And what happens if we were to shift the responsibility to that out to the edges of the data, of the knowledge graph within the organization, of the organizational graph within the business? What would happen if we led through automation? And so that's where these principles came from. And I'm not going to go into much more about this, but what I do want to talk about is, what does this actually look like in practice? And the reason I want to talk about what it actually looks like in practice is because a lot of people have been saying, yeah, we do data mesh, because data mesh is very hypey. Gartner even put it on the on their what is it, tech roadmap or whatever, I forget what it is. They called it, that it will plateau before peak, that it is overhyped or something like that. And obviously we disagree with that assessment. And I think that the reason that we disagree with that assessment is because so many people have a mistaken understanding of what data mesh actually is. We see a lot of data mesh as being an automated way to put tool or data into a data lake. That's part of it. I'll get to that in a minute. But it's not only that. And so what we want to do, and I understand that you probably can't read this, and that's fine. This diagram is not meant to be read. It's meant to be seen and observed, and you're supposed to feel good about it. What we have is a platform that is domain agnostic at the bottom. And when we think about a platform, we don't mean a centralized thing that stands in between producers and consumers. What we mean is a lightweight, composable collection of services that are API-driven, that give you capabilities to work with data that makes sense for what you need to do. So if you need storage, obviously everyone needs storage, you have a storage service as part of your platform. And if you need observability, you have observability tools, you have CI/CD tools as part of your platform. And that platform is not tuned to any given domain or use case. It is domain agnostic. Everyone can use it, and everyone uses it in the same templated, standardized way. Of course, you want to also look at your data governance functions, and you want to look at your cloud strategy teams, and you want to look at your cloud platform engineering teams. They're all a part of that. But the reason that we call this a domain-agnostic data platform is because it actually supports that network of domains that sits on top of it. That's what these bubbles that are arranged in this very nice and highly symmetrical, I spent a lot of time getting that right, sort of arc sitting over that platform. These domains are business functions. They're natural flows of information through the business. It could be your claims processing if you're an insurance company. It could be your customer onboarding if you are a e-commerce company. Those domains would have products. They have software products for certain. They have processes almost certainly. And they probably have data. They have data associated with the jobs that they do. And our argument is that they should own those data products. They should be responsible for the quality. And rather than forcing all of this data through one poor centralized team that has an infinite Jira backlog, we want to say, you know what, talk to each other. If domain 2 needs data from domain 1, if the online claims service needs information from the customer history service, they should be able to talk to each other. There should be interoperability with the data. There should be standards that govern the data. There should be SLAs that mediate the interchange between those teams. And we want to facilitate this through the platform. The platform should be the medium by which we exchange this information, but it should not be the blocker for us to exchange this information. And so this is the sort of idea of the data mesh. The reason that we call it a mesh is because if you assemble all of these nodes and you connect them to each other, it kind of looks like something that is a mesh. Actually, the name came from the idea of a service mesh, even though the ideas are not that related. Of course, when we talk about data products, the data product is actually the core of the data mesh. Right? So in other architectures, you think of a data lake as being the core of your platform, perhaps, or a data warehouse, or a Kafka stream, or something like that. Here, we want to come up with a product architecture that makes sense for what we are actually trying to build. And in this case, we have a producer-oriented data product architecture. This is the type of product that is mostly taking data from operational systems and making it available to others to use. And what you would have in something like this is that each product, this identity boundary, which is this larger hexagon, which you can see in the bold. I don't know if you can see that red dot, but this is sort of your identity boundary. And you have what we call input ports, these little pink circles. These are just ways that the data gets into the product. And you have output ports, which are these yellow circles. And this is how data is accessed from the data product. These can be different types of output ports, and each data product can, of course, support multiple different types of output ports, such as a stream, or an S3 bucket, or a REST API, whatever it is that you want. And the entire processing, the entire lifecycle management lives within inside this boundary. That means that ETL process is owned within that data product. The data quality rules, which are inherited from your platform, are applied in this pipeline. So you are taking in all of these rules, you're applying your own transformations, and at the end of this chain, you're creating these APIs to work with your data, these output ports. Of course, in order to govern this, in order to have that automation, you need these, what we call control ports, which are these little squares down below. These control ports connect to your platform. This is going to be anything that you might need to have to control that data product. We have built dashboards to look at data product development. We look at pipeline lifecycle, for example. We see how many pipelines have failed. We can see if a data product has data quality issues because we can inspect it through those control ports. And in practice, actually, what we do is we set up like a sidecar application with an API that allows us to read and write from that. Of course, you can also set data access permissions through this identity boundary. It's actually much easier to deal with complex access controls because you're able to govern at a very granular level what type of data people are allowed to read. If you have things like PII, if certain fields are flagged as PII or confidential, you can expose that through your contracts in these control ports and in your output ports. And then anybody that inherits from that would then also automatically inherit those properties, and you can enforce that through your governance plane. Of course, your consumer-oriented product architecture is very similar. In this case, we have an analytics use case built on Databricks where we are sourcing the data from multiple other upstream data products. Now you'll see here that I've got 3 input ports here. And actually these input ports are just the output ports of some other data product. So if I have a data product that is serving data, say for example a sales calendar through a REST API, I'm going to just call that API to pull that data in. If I need to get a transaction log from a stream, I can pull it in from that input port. And you can compose multiple data products in this fashion. Of course, you own your processing. You own the business logic of your job. You run that within your own context. Inside of each data product, you have your perhaps AI development. You might have some SQL capabilities. And you might be pushing out through your output ports any number of different types of artifacts. In this case, it could be an analytics dashboard. It could be a nightly BI report. It could be a trained machine learning model. It could be any number of things. And of course, there are data products that sit in between. You can have data products that take data from upstream sources, refine them, compose them with other upstream sources, and then serve those for other use cases. But in any case, the architectural quantum, the fundamental unit, is this data product. That's the basic idea of the data mesh. What have we done? These slides, sorry, I have not dressed these ones up because it's really just a lot of logos. But we actually built this. We've built this several times with our clients, and we have a reference implementation. With this reference implementation, we have built this in multiple clouds. We have a nice little command line interface that allows us to build and deploy data products very quickly. We're talking AWS, it takes you about 30 minutes, a little bit less, maybe 25, depending on AWS's moodiness of the day, to set up a new data product from scratch. And what we do with that is that we have our developer here on the left, and all they do is they write a specification file. It could be a JSON file, it could be YAML. We use JSON in this case. You could pick your own favorite configuration language, right? It doesn't actually matter. And they deploy the spec through a CI/CD process to our platform. There's an AWS platform account that we have that interprets that spec, it validates that spec, and then it does a number of things. First, it checks with Open Policy Agent whether or not you have the permissions to use that data, to read that data, to deploy that application. If so, it registers that product with a data catalog. In this case, we're using Apache Atlas. I'll get into that in a minute. And then it also does a lot of other, nuts and bolts stuff. If you want, it will create a GitLab repo for you. You could do it on any other version control that you choose. We use Grafana for monitoring. You can use anything else. And then what it actually does is it provisions an AWS account per domain team. Why do we do this per domain team? Well, when you have those account boundaries, it becomes a lot easier to have, visibility into the costs of processing your data within that domain. It gives you a lot of granular control over the access boundaries. Within that data product, in this case, with our reference implementation, we're setting up S3 buckets for the input and the output ports. We're setting up a managed web Airflow service. We're setting up Apache Spark, Amazon EMR. And then here we're using Superset and CloudWatch for our observability, for our dashboards, etc. And this is the same deployable unit every time. These are standardized processes from a standardized template. We've tuned them for what our use cases need, and if you have a slightly different set of requirements, we can have a different configuration for that you can use, and then this becomes your deployable unit. This is the it's kind of an analog of like a Docker container. If you imagine a Docker container to be entirely huge and containing an entire Spark cluster and Airflow instance. Of course, this is for simplicity in our implementation. You can also delegate some of that stuff down to the platform layer, as I mentioned earlier. You can have a single Airflow instance and simply create the permissions within it, and you don't have to set up a new service for everything. It can get very expensive that way. And then recently, we also took that implementation and we ported it to Microsoft Azure. So if I wanted to deploy a data product to AWS or to Azure, all I have to do is type a flag in my command line, say deploy to Azure, deploy to AWS. I could set it in the configuration file, but that's not how we programmed it. Don't know why. Doesn't really matter. But it's the same idea, right? Here we're using Databricks under the hood in Azure instead of EMR. Obviously, there's no EMR with Azure. We're using, for our data catalog, we're using Azure Purview, which as it turns out is just Atlas under the hood. It's like a reskinned Atlas, and what we found is that it's not documented, but we can use a lot of the same API calls that we use for Atlas. Again, we're using Azure Data Factory for our orchestration in this case, blob storage for storage for input ports and output ports. And then if we want to set up like Machine Learning Studio, we can set up Machine Learning Studio. Basically whatever you want. All you have to do is you specify in your spec file, I need this. This is the use case that I'm trying to solve. This is what I need, and it provisions that for you. So, what lessons have we learned by doing this? So that was a very fast, hopefully that was fast. Hopefully you're not all bored to tears. That was a rather quick overview of a lot of work that we've done over the last couple of years, both to make this work repeatable so that we can bring it to our clients and get stood up much faster, but also so that we can really just actually develop the practice and the theory of data mesh so that other people can do this as well, right? We don't want to see a lot of like really ad hoc data meshes that don't work because everyone's trying to sort of force the mesh through. We want actually people to develop with data like they develop with software, right? It should be agile, it should be lean, it should be portable to many different clouds. The first lesson that we've had after 4 years of having these conversations, the number one topic that people come to me with and they say, Emily, I love the idea of data mesh, but how do you do governance? That's the number one topic. And it turns out this is actually really hard. The reason that this is hard is that it's for a couple of reasons. But one, data cataloging tools and other lineage data management tools are not set up for decentralized use cases. When you have a decentralized data approach, you have hundreds, if not thousands of people spread out throughout your domains working with data. That, of course, is a good thing. We want to become data-driven companies. That means you should let people work with data. But these catalog tools are, generally speaking, not really, some of them are better than others, but they don't really have the same identity boundaries that we would like to see. Governance means different things to different people that we found out. Of course, the classical sort of triad for data governance is that it's people, oops, throwing that all over the place. It's people, process, and technology. Sometimes you're talking to somebody, and when you talk about data governance, they want to talk about tools. Some people want to talk about process and compliance and how do you sign off on data access. And some people want to talk about people. Who are the governance bodies? Who are the boards that decide what the policies are? In that domain-centric model, we say that data is a product. It's a domain-owned data product. That means that we have to have a product owner, and it turns out that nobody knows what a data product owner is, because it's literally a role that we made up. So of course nobody knows how to do it. We need to do better at defining what those requirements are, what those boundaries are. And there's a massive responsibility that we're actually shifting upstream. The idea behind shifting left. You've probably heard it in agile development, shift left on quality, shift left on security. We're trying to shift left with data and data governance. But it turns out, if you're a producing team, what's in it for you? Why do you care about the data mesh? Why are you going to take on all of this extra work to quality assure your data and adhere to SLOs and SLAs? What's in it for you? There are answers to that. But in order to come up with those answers, we have to think about how we are transforming our businesses, how we are reshaping the organization. Again, this is a socio-technical transformation. It is a social change. If you're not going to have a social change in your business, data mesh won't work because people are going to just fall back into their same patterns. Lesson number 2. You can try to start bottom up with data mesh, but you're eventually going to need the executive sponsorship. We have tried a couple of times where clients have come and they said, we have a limited budget, can you start a data mesh with this pot of money? And what we've said is, sure, we can build you a data product in the style of data mesh. And what we found is that if that stakeholder does not have influence over the business, over the IT, over the platform, whatever it might be, you might be able to deliver a really great data product, but you're not going to get the change to stick. You're not going to convince anyone else to interoperate with that data product because they're not aligned with the transformation. So we're not saying don't start small. You want to start small, but you have to couple that small start to a top-down, executive-sponsored approach. Of course, everyone has a different concept of domain. Some people think that domain means business unit. Some people think domain means application area. And this is a challenge. We see that business and IT are not always aligned. Sometimes our business stakeholders bring us in, but our IT stakeholders have a different cloud strategy, a different data strategy. We have to align all of that. That's very challenging. Oops, that's the wrong direction. Lesson number 3 is that what people really care about is data as a product. Actually, if you strip down those 4 principles that I showed earlier, if you strip down those 4 principles that I showed you earlier, the one that people really care about the most is data as a product. This is what actually brings money. If you have a self-service platform, that's really nice. You're very proud of you for building a cool self-service platform, but if nobody's using it, it's not making you any money. Data products are the things that have value. They're the things where you get money out of data, which is what we all want to do. And in order to do that, we need to focus on our user experience. We need to think about who is using our data, what are they using it for, how do we add value to them, what are the SLOs that we need to provide. Is it latency, is it accuracy, is it freshness, whatever that might be. They don't really care, like data users, if you talk to your average analyst and you say, I've got a really cool data architecture, they're gonna say, great, what's in it for me? Because what they want to do is they want to work with data. They just want their data to be good. If you tell them, oh, the new data architecture will make your data good, they'll probably be very happy. But they're not often really concerned about the architecture because they're not working through that whole stack. They're just working on their context. The state of data reliability engineering is quite poor. I'm going to get into this in a minute. One of the pain points that has led data mesh to be so attractive is that data mesh promises you something. Data mesh promises you faster and easier access to get data. That's a really compelling story. But sometimes the root cause of why people care about that is that sometimes we just have tools and services and platforms that just aren't very good. Sometimes we have data quality that's just not very good. And if you don't have that, if you can't solve that problem independently, data mesh won't necessarily address it either. You have to work on data reliability. And of course, data literacy, we see these same challenges, right? It's I've been in the industry for a very long time, and here today, late November 2023, people are still emailing Excel files to each other, and that is the state of data literacy. Why are they doing that? I'll get into that in a minute, but if we don't have people that can think in terms of automating and getting value out of data and getting away from ad hoc analyses and stopping the data pull question and thinking about asking questions of our data that are meaningful, we're not going to necessarily have the momentum to sustain a transformation. So we actually have to work on the culture of data at companies as well. But it does prove that this approach is valuable. When we have built data mesh with our clients who have really embraced this idea, we've seen massive and immediate benefits. One of our clients told me, or told us once, we've been trying to get this data for 5 years. You guys did it in 2 months with data mesh. And that's a very doable thing. And we have heard these stories over and over and over. Even people that we don't work with. I was at on a panel, an industry panel, somebody totally not working with, we don't work with this company. He says, I've been trying to get access to data for 10 years, and it didn't work, and we built a data mesh, and I got it in 3 weeks. It was great. So we want to do this. We want to have data as a product. We want to have high-quality data. The lesson number 4 is that we need DevOps foundations if any of this is going to work. It actually doesn't really matter if you build another great architecture if you don't have fundamentals for how to work with it in a decentralized manner. It's the same reason why 10 years ago everyone said data lake, you have to have a data lake. If you don't have a data lake, how can your data scientists ever do data science? They need the raw data. And of course, I'm a data scientist, right? And we're always saying, but we're spending 80% of our time cleaning data. We're always complaining about data. Data scientists are not the most fun stakeholders because we're never happy. We're always wanting bigger computers and more data and better data and cleaner data. And then we just throw an artifact over and they say, look, we built a chat GPT. Society crumbles because of it. But we actually need these DevOps foundations, right? There's a lot of low-hanging fruit out there. There's a lot of benefit that can be made just by doing things like integrating data quality tests into your pipelines in an automated fashion, creating testable ingestion scripts that you can validate in a CI/CD pipeline, adding observability that is context dependent, creating things like custom data quality checks for your data. All of that is a really low bar to clear. If you can't set that up, then you can't make data mesh work. So sometimes you might want to just start with establishing the foundations in your centralized data teams and then bringing that out to the edge. The tooling is still not the greatest. It's getting there, it's getting better. Things like one of the talks I was just in with GCP talking about Cloud Composer 2, it takes 30 minutes to deploy updates. That's when you're working, if you've ever worked in a true test-driven trunk-based paradigm and you're deploying code and you're pushing code every 30 minutes, 40 minutes, 5 minutes even, and you're deploying to production multiple times a day, and then you've got this process that takes 30 plus minutes just to deploy, the cycle time, I mean, even in your test environment, the cycle times are just so painful that you're never going to get to that point. And then, of course, data engineers are really expensive. That's great for all of us. Congratulations. And they're hard to find. We're hiring, by the way. I'll have a slide on that. But it's tough to scale. It's tough to scale that out, right? So we want to set up the foundations, the fundamental practices. We want to remove the mysticism from working with data, and we want to make it standard and repeatable. So I told you, I promised you in the title of this talk, I would tell you about what works and what doesn't. I have 3 slides on this. Then I'm almost done. I promise we're going to get drinks soon. So first and foremost, org change, right? Data mesh, it's an org change topic. It's not a technical topic first. It's an org change topic first. I mentioned already bottom-up influences with no, or bottom-up approaches with no organizational influence. They're probably going to stall. You might get really good value with one data product, but if you don't build up that influence, if you're not socializing the impact of that change from day one, you're not going to be able to continue that to the 2nd and 3rd and 4th data product. You can't just build one data product and expect it to become a data mesh. A mesh needs at least 2 things, and then you just really have a string. You need 3 things, and then you have a triangle. You really actually need to build many data products in order to have a mesh. And then one of the mistakes that people make, sort of on the flip side, is trying to start too large. They try to say, you know what, we're going to map out every domain, we're going to map out every data product, every use case. I'm going to have the golden roadmap, and with this roadmap, I will conquer the world. That doesn't work either because things are too fluid. And it's all of the challenges of what is a domain, who owns this data product. You actually don't need to answer all of those at the beginning. You just need to get started. You just need to get started and understand that you're going to change and learn as you go. What does work is leading by example. You scale out the technology from one data product to another. You make things repeatable. You take a thin slice approach. You build end to end. You don't sit there and say, I'm going to build my self-service platform. Don't come here. My self-service platform is not perfect yet. When it's perfect, I'll let you know. Now you say, you know what? I just moved in. I've got boxes all over the place. My flat is set up. There's holes in the wall. But cool, you can come over. Let's have some drinks. Let's party. It's great. We're going to build that. We're going to learn, and we're going to go from there. You need executive sponsorship, as I've mentioned already, and you need to keep showing the incremental results. Federated governance. What works and what doesn't here? Just expecting a new tool, a new catalog, a new dashboard to solve all of your problems. I've been really rough on the tools, I'm sorry. There's tooling vendors in the audience today, and sponsors too. I don't really mean to beat you up. You're doing really great work. It's just that nobody has ever really thought about decentralizing at this scale. And so, of course, it's going to be hard to do that. We are in this sort of space with data where we just kind of like can only see the challenge in front of us. And I talked to a lot of people that are like, if only I had a data catalog, all my problems would be solved. And you build a data catalog, and if only I had lineage, all my problems would be solved. If only I had a data lake, all my problems would be solved, right? And it's been like that for 15 years, 20 years in the data space. Re-implementing centralized governance structures, right? So sometimes we say, you know what we're going to decentralize? First thing we need to do, we need to set up a governance structure. It's going to be these people, and they're going to have approving roles and sign-off roles, and nothing's going to get done until they say so. You're like, but didn't you just say you're going to decentralize? So we don't want to do that. We want to actually shift this responsibility out, which means we need to have new roles and responsibilities and define those and automate those and check those. Coming up with those automated policies and the engine to do that, that's actually kind of hard to do. It is possible. It's a lot of work. But if you do that, it becomes easier and easier. And part of what we do with our spec-driven approach is that when I specify, I'll show you a spec in a minute. When I specify a data product, I say what the fields are. I say what the upstream products are. I can lift my entire knowledge graph just by compiling those specs. It's a trivial problem to solve, right? And we can build that into our data catalogs. We can build that and those quality checks into our deployment time controls, right? Creating sort of these cross-functional governance teams of practitioners, right? We want people who are working with data, who actually have a stake in what decisions are made and what policies are being enforced. And we want them to be controlled by conventional roles, right? Maybe you are a lawyer, but not all of you are lawyers. I'm not speaking at a lawyer conference, right? So you are probably not all experts on data privacy regulation. If you want to build a data mesh, you need to talk to your data privacy experts. But they don't need to be in that centralized function as a bottleneck. They need to advise you on what you should be building to make this easy to scale out. Third, self-service platforms. We want to create these deployable units. Here again, I think one of the earlier talks that I was in over in Hall 1 today talked about some of the challenges with cloud-native services, right? Like Glue. Glue doesn't have, you can't use Glue in a multi-cloud setup. It doesn't have some open source libraries that you need in order to make it work. Things like lake formation don't integrate well with the role-based access control schemes that you might want to do at that scale. And so there's all sorts of challenges, right, with getting the cloud-native tooling to work. And I don't mean to lake formation is great, Glue is great. These are great pieces of technology. I don't want to feel like I'm belittling them or saying that you shouldn't use them or that you made a bad choice by using them. But some of them need to be thought, we need to think about how we're using them if we want to use a data mesh, if we want to build a data mesh. And then oftentimes we see, hey, can a data mesh build me my single source of truth master data? And then we say, you know what? Maybe it's going to be a lot of work, and I don't think that you actually want to do that. Because actually what we want to do with these polyglot output ports, with these fluid in changing and evolving data products is to make the right contextual source of truth visible for the right users. If you have a stream of data that has a sales transaction log, right? That if you process that at any given time, you might not be perfectly accurate, right? Because some orders might be canceled in the future, right? There might be other issues that come up with processing that log. So you might not want to use that for reporting to the government on how many units you sold, right? You might want a different process for that. But if you're building a recommendation engine for machine learning and you just want fast information, right? That might be very good. You don't care about if it's accurate. You don't care about the small changes that might happen with a late arriving event or with a cancellation, right? It's just not important. It kind of washes out in the noise. What does work is we want to actually use the cloud the way that it's been built, right? We have, you can do an AWS account per domain, as I showed earlier. An Azure resource group per domain, really easy to set up. Really great because you can do really granular cost controls. You have granular observability per domain. And doing that actually works really great. I've seen some setups where there's just one big AWS account for the entire company. And that multi-tenancy problem, I wouldn't build a data mesh in a multi-tenancy environment like that because you're just asking for trouble. And then multi-cloud deployments actually get really easy once you have set that platform foundation, because those platform components, those composable, lightweight APIs, don't really care about what cloud you're talking to, as long as you say, you know what, I need storage in S3, I need storage in Azure Blob, I need storage in GCS, whatever. It's fine. You can do that. It's a matter of just building out that infrastructure. So you can actually build multi-cloud really easily with this. Finally, and I'm going to take us home here, what do we still have to learn? Sharing data across company boundaries is really easy if you do this right. It's not easy unless you do this right. And we need to think about how do we actually build data products that can control governance across these organizational sort of discontinuities. We still need to figure out how to automate that governance across these boundaries, right? What are the contracts that you need to put in place? What are the controls that you need to put in place? Is there a data meshy way to do this? Or are the ways that we're doing this now actually just something that we need to work around, right? Do we have the best solution currently? Or do we need to create something better? I don't know what that is. We have a lot of people talking about this right now. How do you come up with a data mesh spec so that companies on both sides of that boundary can be using the same standards? But right now, I don't, there's not a standard that we can point to say, you know what, if you do this, then you're going to be fine. So we need to figure that out. I don't know that that's a solvable problem, I'll be honest. Dashboards and reports, right? Most data operations are being done with tools like Excel. I mentioned this, right? When we say self-service data platform, we're often talking about like a Kubernetes type of situation. But most people, when they see self-service data, they're thinking about Tableau or Power BI or something like that. And then, of course, the problem with this is that there's a lot of logic. There's a scary amount of logic that steers our businesses, that we use, our leaders make decisions based on, that are built on untestable, unverifiable logic living in these systems. There are Excel spreadsheets that are load-bearing within your business that are written with like VBA that nobody has tested, and you just have to take it on blind faith that they're correct. Because God forbid you ever try to like actually figure out what the logic is. And some of these scripts are 10, 15 years old, right? Why do these tools exist? Well, Excel is great, actually. Excel's amazing. Why is it amazing? Because you can open it and you can just do things with it. You can't open like MicroStrategy or something and do the same things that you want to do with Excel. You can't open most dashboarding tools. You're very limited in what you can do, right? If you build a report, you're just looking at the report. You have to regenerate it. If you want to get the updates, you have to change SQL logic if you want to do something. Everyone can use Excel. It's taught in high schools. There's a ton of logic in there. How do we actually work with that? How do we bring that information into a data mesh so that we can actually govern it? This is an open question that I don't know that we have an answer to. We still need to respect those workflows. And then finally, the question that we get all the time, what is the difference between data mesh and data fabric? I mean, like, isn't fabric a mesh, and isn't mesh a kind of fabric? And what's with this lake house? Do I wear my mesh to the lake house? Are these really competing ideas? And for me, the answer is no, because data mesh is about data products, right? We actually don't care about the infrastructure. We want it to be self-service. We want it to have these nice things. We want it to have these really clean properties. But actually, if you build data products that interoperate, that's what a data mesh is all about. So I personally, I think that you can actually build a data mesh within a data fabric. I think that you can definitely build a data mesh within a lakehouse concept. Now, is it going to be a pure, ideal, platonic image of a data mesh? No, probably not. But has anyone ever built that? I haven't seen it. We've been doing this, I mean, we invented the concept 4 years ago, been working in most of the projects, I'm familiar with almost all of them that we've worked on, and I have not seen the pure data mesh at a company yet. And that's okay. It's okay to not have the pure data mesh, and I don't actually care if you are doing everything to those 4 principles. What I care about is that you're actually able to work with your data, and that you're actually, well, I have more time than I thought, that I have plenty of, that we have plenty of access to data, that we have high reliability of data, and that we can do new things with the data. So I will wrap up there. We have some time for questions. I did mention I have to do one plug. I'm being paid to be here. So we are hiring. We're looking for data engineers throughout Europe. If you're interested, there's a QR code. I'll leave that up there for another 30 seconds or so it doesn't get super awkward. But I'm happy to take the questions. Thank you.